Hi, I'm Pagata12, and in this one we take further the idea from the previous tier and we'll compute the intersection point of line BM and line AC. This is another exclusive tutorial for you. Thank you so much for your support. Before we start, I would like to see the full triangle, and so here, instead of taking into this top to the noise texture, I'll go with the group, and I need the first point once again here. So let's take nearest pixels, and here we group right to 4 pixels. Okay, so by having repeat here for the extend, we good, and let's go with this texture. Okay, now we have the line, and I can also see the line BM. Okay, so with 2 selects, maybe, so it's much cleaner. This one is M, and again I need another one to take the B, which is this one, and now I'll use layout. Okay, and this layout go with 2 by 1 and nearest pixels and resolution. Okay, now we good. Let's name this BM. Okay, chop to top 2 actually. Okay, and let's go with chop to SOP, and here instead of txtytz we go with rgb. Okay, and let's see the line. Now, how I plan to find the intersection is actually an approximation, and I would like to have a little drawing here. So once again we have the 3 points. Okay, so like this, it's A, B, and C, and we know also the bisector line here. It's M. Okay, and let me draw the AC line with a different color, like this. Now, whatever point it's here, if I consider the vector, let's have a different color. Let's mark here this point. I will have this vector. Okay, maybe if we find a good letter for this point, let's have this P. Okay, and PA vector, and also PC vector. Now, those vectors, if I normalize them, and one of them, the orange one, I multiply with -1, then I'll have 2 vectors which are actually identical. Okay, and what I plan to do is find a point in this line BM which has the little difference for those vectors, and so what we need to do is actually multiply the orange one with minus, and so I'll get this. Okay, something like that. And then since these blue and orange vectors are different in length, I can normalize them. The only thing I'm interested in is the direction. Okay, so if the directions are similar, the point is on the line, or in our case we take the smallest difference between those 2 vectors. Okay, how we do that in Touchdesigner? Okay, let's first let's set some points on a BM line. Okay, so I'll have a constant here and maybe divisions or steps. Yeah, steps. Okay, so I will go with 8 steps for now. Okay, and obviously I want 8 points in a BM line. And how can I do that? I did a tutorial about interpolation some time ago, and I will link the description below. However, this takes only 2 tops, and first one is resolution. So I'll go with resolution, and I'll take the number of steps multiplied by 2 here for the resolution. So in common, custom, resolutions, so steps multiplied by 2, and here we have 1, and yeah, let's take interpolate pixels here and here resolution. Now we have something, a lot of points, but the extreme ones are duplicates, and we want to trim them out. We group out the extremes, so we use a group here, and we go left and right pixels, both of them, and we group half of the steps, so steps divided by 2. Okay, and here we group steps multiplied by 2 minus half of the steps, so minus, we good. So yeah, let's go with nearest and nearest. Okay, and yeah, those points are here. Okay, and let's see them. Okay, so I will copy this geometry. Okay, and let me see, I don't oh, so I'll take the group for the color and also the group for the position, like this. So yeah, we have the points. You notice the B and A, the points, will become a little inside. It's how the resolution texture works, and you can correct that by stretching back. But in our case is just fine. So we want to find out the vectors between those points and the A and C points. Okay, and how we do that? Let's see. So I would like to also take A and C, and I can grab it with select out of here. So now we good, and I need to cut out the first pixel here. So I'll go with the group. Okay, and yeah, I will group 1 pixel left. Okay. We good. So let's name this CA. Okay. And so I need to subtract, let me see, those points out of C and those points out of A. How can we do that? So I'm thinking if we go with this texture to flip and bottom left, okay, Are we good? And let's have these points. I duplicate the line. Okay, so I go with the fit, and this fit takes the steps by 2. So now I'll take nearest pixels and I go with fill. So I have 2 identical rows. Okay, and now I can subtract those points out of the A and C, and I go with subtract like this, and let's see here, interpolate pixels, transform. Yeah, we good. And now let's split the textures, as I would like to normalize the vectors. Okay, so let me think. Yeah, we can normalize them with one texture. Let's put a null. Sorry about that. So let's have a null here. Okay, and I will go with a null in between and collapse selected. Okay, so I can name this normalize. Actually, if I'm thinking this is the same, we used it before, and so yeah, there's no need to build another one. So let's see. Yeah, this is perfect. Let's go inside and go for nearest pixels. Okay, we're good. Now I want to multiply one of them with -1. As we see here, the black ones are oriented down to minus. Okay, so yeah, if I multiply that with -1, I'll be good, and I believe I can have a texture like I don't know, 0 and let me think. So 1 and -1. Okay, so let's have a constant. Okay, and this is 1. We go with the nearest pixels, 32 mono, and 1 by 1 pixel. Okay, I use a mod to multiply this with -1. Okay, and I form a texture on a 1 by 2 layout. Okay, and here it's custom resolution 1 by 2 resolution. Okay, and we go top to bottom. We good. Okay, and now I multiply you see. Okay, now I have those vectors. I need to find where is the smallest difference in the vector, the top vector and the bottom vector for each column. Okay, obviously somewhere here maybe. Okay, and how we do that, we can let me we split the screen. So we go with group here, and okay, we So this is bottom, okay. This is vectors from those points to the C, okay, but obviously inverted, okay. And now here I'll go with 1 and 2 here. So let me check. Oh, I need pixels, so sorry about that. It's not okay. I delete this. It's here, bottom and top. So 1 and 2, we good. And now I would like to make the difference, okay, of those pixels. And I go with difference, okay. And yeah. And now I would like to check the length of the differences, okay. I can also go with subtract. I believe it's better subtract. Yeah, let's go with this. Yeah, much better, because sometimes we with subtract we can get some minus results, and but with difference you only get positive difference. So we good. And here we find the length with the mod, okay. So we go for length, mask the alpha 32 mono and the nearest pixels, okay. And now I would like to see where is the smallest difference, okay. And for that I take analyze, okay, and go with the minimum, okay. And now I will do some difference, okay, between those two pixels, those two textures, okay. I want to find out where the pixel where I have 0. So obviously by making the difference, okay, you see here in the close to black pixel, there I have my result, but I need a texture with only white and black, 0 and 1, to select that value. And here in this difference, after this we go with mod with ceiling. So yeah, and yeah, we can invert that with again with a level, or yeah, I can switch here, and then I need to take instead of ceiling I need to take floor, and this is my my point, okay. And now the value for this point, I need to multiply this texture with let me check. So multiply with the texture where I have all my points, okay, in BM line. So where is that? It's this one. So I select this group here, okay, and just a second to open to my dog. Okay, so now I will multiply those two. Okay. Now I only want that pixel out, so I can use an analyze here, and I'll go with maximum, and I'll have that, since everything else it's black, it's 0. Okay, so now is this the point? Now let's see that point first. We don't need to look here, okay, and we use this analyze. So maybe if we call this P, okay, and for the color I believe also. Okay. And yeah, this is the approximation for the point. Now, obviously, 8 steps are way too small a number to get a precise point. But what if we go here with 1024? And now I have my point there. So if now we play the noise, that point will always stay there. Okay. Now sometimes you can notice some jiggling there, some situation. The approximation is jumping from one position to another position, but you can increase even more this number here, okay, by a lot, and you'll get a very smooth result. So yeah, this was the trick that I use for approximation, and this works only if the segment lines already are overlaid. They are intersecting. You know that there is a point of intersection. Okay, if you have the segments like this, you know, and they don't intersect. Yeah, this method doesn't work. So this was my tutorial. I really hope you like this. And yeah, see you in the next one. A big thanks to all my patrons, especially to Andreas Fischer, Anti Elias, Aurelio Adoratorio, Bora Edintug, Brandon Tay, Breakwood, Brian Smith, Chad Alessi, Charlie Williams, Choi Seng Ho, Kono Cars, Crocondale, Daniel Clark, Darian Brito, Erin Lewin, Esteban, ATVM, Fraxinus, Jason Picciano, Leo Torres, Leures Lab, Masayuki Azegami, Migumian Slung, Ophir Lieberman, Paul Trull, Ploy Papus Fosri, Brian Givord, Robert Elderton, Sebastian Schnabel, Sinus, Cyril Bridger, Siskil Me, Tim, Tosca Teran, Tyler Hallett, Vincent Naples, Yish Xian Lin, Yuxi Kao. Guys, thank you so much.